In our next section, we're going to talk about content-based access control, or the CBAC feature set, which was previously known as the iOS firewall feature set, which is one step above the reflexive access list that we talked about, but one step below the zone-based policy firewall, or the zone firewall, which is a new syntax wrapper for the CBAC feature set. Now, the main difference between CBAC and what we previously saw with the reflexive access list is that CBAC adds true stateful inspection to iOS because it does per protocol specific inspection. Now, the protocols are going to be matched based on their port numbers, which we consider the port to application mapping, or PAM. And once the protocol is matched, there is going to be a specific inspection rule that applies to that individual protocol. Now, from a configuration point of view, we define these with the IP inspect command, specify a rule, and specify what particular applications that we want to inspect. But the key is that the router is able to know that for non-standard applications, for example, H.323 phone calls or an FTP data transfer, that it knows what is the expected inbound return flow for something that was a non-standard outbound flow. Now, again, the problem that we talked about with the case of reflexive access lists is that if router 3 is our firewall and we are watching traffic as it comes from the inside network and goes outbound, the reflexive access list takes this entry and copies it to the state table. Now, inside the state table, it's going to take the source address, the destination address, the TCP or UDP port values, and it is going to flip them around. It's going to take a mirror image of them. So this means that when the return flow comes back in, unless it is an exact match for what is in the state table, it's going to be dropped. So CBAC natively fixes this problem because it knows, based on the specific application signature, whether it's a phone call or whether it's like a SQL transfer, it knows what is the port number, it knows what is the particular payload, and it can also do deep packet inspection as well. So from a configuration point of view, we're going to configure our inspection rule. We're going to apply that rule either inbound or outbound on the interface. Then when traffic returns, the state table is going to be processed before the access list deny. So where the difference was with the reflexive access list, when we went to the CLI and we look at the show access list, we would see these entries in the state table that were for the particular reflexive list. In the case of CBAC, there's going to be a separate connection table that is unrelated to the access list. So the access list on the interface could simply say deny all traffic, but the state table is going to be processed previous to that in the order of operations, which means that any inspected flow should automatically return back inbound. And we'll talk about in more detail shortly here what is that order of operations and how does it affect different types of traffic. Now, as I mentioned, from a classification point of view, the way that CBAC does this is through the feature we call the port to application mapping, or PAM. And PAM can be customized with the IP port map command. So for example, if we were to have a web server that's listening on port 8080 as opposed to regular standard port 80, then we're going to need to configure the router to say, also classify this particular traffic with that individual inspection engine. Now, this can get a little bit confusing though, because the command that we're using for this, the IP port map, there is also a similar command that is the IP nbar port map that is used for network-based application recognition with quality of service. But technically, these commands are unrelated. IP port map is going to be for the firewall feature set in CBAC and the zone firewall, where the IP nbar port map is just for a QoS policy. Now, when we look at the command line, if we go to router 3 and look at the show IP port map, this tells us what are the current entries for the port to application mapping. So we can see, for example, that SNMP is UDP port 161, or that bootp client, which would be our DHCP request, is UDP port 68. TACACS is Actually, this should be TCP49, but some of these you'll see it maps them as both. But the main point being that when you look at this output of the show IP port map, it tells you what the CBAC or what the zone-based firewall can inspect and what the particular port mappings for that application are. Now again, we can also change this if the service is running on some sort of non-standard port. So if we were to say IP port map for our particular protocol, let's say for web traffic, for example, what is the port number? And if we look at the show IP port map, pipe include HTTP, we can see right now it's listening for clear text HTTP on port 80 and SSL on port 443, which of course are the default values. Now if we were to change this, if we were to say HTTP is also running on TCP 8080, it's going to take the default match plus this new user-defined one. So it's not going to override it. It's still going to take what the system-defined default is there. But we're saying now when we do an IP inspect and say the protocol is HTTP, it's also looking in the classifier for any TCP port 8080 traffic, and then that can go through the web-specific application inspection. Now we can also configure this application mapping on a per host or a per subnet basis. So when we specify what the protocol is and what the particular ports are, we can also call an access list to say that most web servers are running default port 80, but maybe we have one specific server that is running on the non-standard port and we want to do the remapping just for that particular one. But again, the main point being of this, when you look at the show IP N-bar port map versus the show IP port map, these are two unrelated features that just happen to have similar syntax configuration. So when we change the IP port mapping, this is for content-based access control, the IP inspect command, or for the zone-based firewall. If we were to change the IP N-bar port map, this is for the class map match protocol for a QoS policy. Now beyond doing the regular inspection, CBAC can also log the session data for us. By default, it logs what is considered alerts, which are essentially protocol violations. Like if we're undergoing a SYN attack, it's going to know and it's going to generate a syslog message for that. This is on by default, but it could be globally disabled or disabled per inspection. So if we go to the documentation and we go to let's go back to security. Let's say under 15.2t, under reference guides, the command reference for security, this is going to be under IP inspect. You could see that there's not too many commands that relate to the feature, but we can say when we do the inspection name, this is where the actual application inspections are. So for web inspection, we could say there's a Java access list, there's a URL filter for doing the payload inspection. We could say are alerts on or off, and whether the audit trail is on or off. So alerts are on by default, which is a logging of protocol violations. The audit trail, which is a log of the actual flow data, this is off by default. So the audit trail could be enabled globally or enabled per inspection. This one is off, but we can log this. The disadvantage of doing this, though, is that it generates a lot of information. It's logging the individual flow data. So this is more of like a troubleshooting tool. If for some reason the firewall is not behaving as we think it should, we could turn the audit trail on just for that inspection and then look at the actual traffic flow and figure out, is this correctly what we thought it should be outbound, and what happens when the return flow comes back inbound. Otherwise, generating all these syslog messages could be very CPU intensive for the router. Now, additionally, we can log the dropped packets. For CBAC, we'll see that there are two different ways that we can do this. One is going to be the command that is ipinspect log drop-packet versus doing a regular drop and log in an access list. And there is a difference between these. The first of which is going to be when there is a problem in the inspection engine and it's dropping the packet for some sort of malformed reason. So maybe the header length is too long for web browsing, or it has some sort of invalid IP option that we're trying to protect against. So this is only going to be for something that is being inspected, and then for some reason the inspection fails, like it's a crafted TCP packet in order to do some sort of buffer overflow. So if the router catches that and it's a violation of the firewall policy, that's going to be dropped and logged with the IP inspect log drop packet. The regular access list drop and log, this is the one that is very CPU intensive that we talked about before, because all drop packets then are going to be process switched in order to generate the log message. So if you want to figure out, is someone doing an attack through the network, the alerts by default will show you the protocol violations, or you can also turn on the logging of the drop packets. But in general, on the ACL, you don't want to say drop log unless it's some very specific thing that you're trying to troubleshoot for the flow. Now again, in our particular case, within the scope of the lab exam, we will want to end the access list in drop log, because that will tell us, are there particular protocols that we needed to account for in a manual exception, but we forgot to. So again, things like our OSPF hellos, BGP keep alives, those are not going to be inspected by the CBAC engine by default. So similar to the reflexive access list, it is going to have some problem with the locally originated traffic. So the local traffic is not subject to the outbound inspection is what the problem is. So if the router is forming a BGP peering to someone else, the TCP session that the router generates locally is not going to hit the inspection. So it's an order of operations issue on the traffic leaving the interface. Now we'll see that there is a minor exception to this for CBAC, where we have an option on the inspection that is router-traffic, but this is not going to work for all protocols. It's going to work for some of them, like BGP, but it's not going to work for other non-TCP, UDP, or ICMP protocols. So for things like OSPF or EIGRP adjacency, we still will need manual exceptions for the return flows, because these non-supported protocols, we cannot inspect them as the traffic leaves the router. Okay, same is going to be true of an IPsec tunnel. If the router locally is originating a LAN-to-LAN tunnel, or if it is an EasyVPN server endpoint or EasyVPN client, we will need to take that into account when we're combining it with the firewall. So these type of more advanced flows, we will talk about them later when we start to build the topology larger. As we get into IPsec, LAN-to-LAN, and remote access, we will be revisiting how do those features interact with the firewall feature sets, how do they interact with network address translation, because there are order of operations issues that we do need to talk about and to take into account with them. Now, the previous feature that we had talked about, TCP intercept, this is also a feature that is integrated into CBAC, and that was the reason that I wanted to talk about TCP intercept first, because intercept is always on when we are doing CBAC inspection. Now, it doesn't support the intercept mode, which is fine because we previously saw if the router is doing the intercept mode, we're basically offloading the DOS attack from the server onto the router, and that doesn't make any sense to do that. So we don't want the router to be a proxy for the TCP sessions. We just want it to be passively tracking the traffic that is going through the inspection. Then if we see too many half-open sessions per host or per minute or overall, then we can start clamping down on them and then resetting them back to the server. So we'll see, like in TCP intercept, there's a bunch of manual options that we can change here. So what's the maximum number of embryonic or half-open sessions? What's the number per minute? What's the maximum number of incomplete sessions per host? And then also, how much time are we going to wait before we get the SYN back from the SYN ACK response actually back from the server, which is going to be the SYN wait time. So again, these type of options, you don't need to memorize them. You just want to know where they are documented, which again here is under the security command reference under IP for IP inspect. And once you look through these, mostly they're self-explanatory. So what's max incomplete high low? 1 minute high-low per user, etc. Now, the normal flow logic that we'll see for CBAC is the same goal as we have in the reflexive access list or in the ASA firewall, where basically we want to track the traffic as it is coming from the inside going to the outside. So watch this flow as it leaves. Then as the return flow tries to come back, Router 3 is going to decide, do we drop this, or is this going to be allowed based on the session data of the originator? So if the test PC here is talking to a web server, and as long as we are inspecting TCP port 80, when the SYN goes out, the firewall should allow the second portion, which is the SYN-ACK. So again, goal is that we're going to be watching the traffic as it leaves. We're then going to permit the established flows that return, so this is based on our session data. And if there's not a match in the session table, then we're going to fall back to the access list that is on the interface. This is where we would put our manual exceptions for things that the CBAC inspection engine cannot deal with. So our OSPF hellos, EIGRP hellos, our VPN traffic. Generally, this is going to be the local control plane traffic, plus any type of custom application that we're using in the network, but it doesn't have an actual application engine for it. Now, the problem with doing this, though, is that the ACL drop on the ingress interface. So if we're applying the inspection out, and then we're using the inspection engine on the way back in to say, is it permitted? If not, check the ACL for the deny. This is a pretty CPU-intensive process to search through the ACL in order to do the dropping. So there's an additional feature we're going to look at here, which is the IP inspect TCP block non-session. This command actually changes the order of operation of what happens when the return flows come back in. So normally we inspect the flows as they go out. When the return traffic comes back, we're going to permit the established flows. But with this additional command that block non-session, if there's not a match in the session table, all other TCP traffic is going to be dropped. Only once we get to that point are we then going to check the interface ACL for permit or deny exceptions. Now we'll see that this command is only going to take effect for the TCP sessions. It doesn't have anything to do with UDP or ICMP packets, but you need to be careful with this. If this command were configured, let's say for like a troubleshooting point of view in the exam, if they put this command as a default, you would not be able to configure an ingress ACL on the router to say allow my BGP session or allow my SSL VPN port 443 to someone that is behind me. It's saying only allow the traffic that's in the session table and drop all other TCP flows, because it's less CPU intensive to use the inspection engine for dropping than it is to do a linear search on the access list and figure out where is the drop. But this feature is off by default. It does not block the non-sessions. It's going to check the returning flows against the session table, and then it's going to check the interface ACL for any of the exceptions. So again, in our particular design here, we're going to be using Router 3 as the firewall. And we're going to say that the traffic that is coming from Router 1, this is the inside, and from the test PC, this is the inside. Going out to Router 2, this is our outside. So the goal here is that we want to watch the traffic as it's leaving in both of these directions. Then when traffic comes back in, this is where Router 3 is going to decide, is the traffic in the session table? If not, check the ACL, and then if there's not a permit in the ACL, it's going to go down to the bottom of that, which is our implicit deny. Now, if we compare this to the previous implementation of the reflexive access list, let's look at Router 3, and on that interface, which is F00.23, if we show run interface F0023, previously with the reflexive ACLs, we were watching the traffic go out, This is where we have that reflect statement. Then as the traffic is returning, this is where we're doing the evaluate. Now in the case of IP inspect, we do not need the egress ACL. We only need an ACL that is the opposite direction of the inspection. So if we're inspecting the traffic as it goes out, then we only need an ingress ACL. If we're inspecting the traffic as it comes in, then we only need an egress ACL. So it's going to be the opposite direction. The ACL is the opposite direction of what the inspection is. So here on router 3, to start, I'm going to remove these two previous lists that we had. Okay, next we're going to define our inspection list. So IP inspect, give it a name. We'll say this is our CBAC rule. And now we have the option of what is the particular protocol. So if we look through these just quickly, you can see that there's a lot of different applications that the router supports for the inspection. So some of these will be standard applications, like we could say inspect network time protocol. We know that the outbound flow is going to be UDP 123 and the inbound flow is going to be UDP 123. But other things that we have to look into the payload, for example, we can do BitTorrent or we can do Citrix. So things that are not necessarily straightforward just to look at the layer 3 or layer 4 header and figure out that this is the particular traffic that is returning. So depending on which ones you want to use, we're going to have to list these individually. There's no command that says like IP inspect all traffic. Now additionally, more specific inspections are going to take precedence over less specific ones. So if we were to say our CBAC rule is going to inspect HTTP, but it's also going to inspect TCP, well, we know that web browsing uses TCP for a transport, but the inspection engine is then going to use the most specific one. So we could say kind of our fallback match here would be to inspect TCP, UDP, and ICMP, and then we add whatever specific in other inspections that we want, like we want POP3 mail, or we want send mail, SMTP. So likewise, these are still using TCP, but it's going to use this individual inspection engine as opposed to the TCP one. Now, if we look at the options on the individual inspections, the options will be different depending on which particular application engine that we're using. Now, again, you can see this documented under the IP inspect name command in the command reference. It talks about what's the syntax for web inspection versus mail versus, a user-defined application. We could say create a custom application under the port to application mapping. So let's say I have some sort of TCP application that is a custom protocol. We're going to say IP port map, and we give it there should be an entry here for user-defined application. So it says use the prefix user dash. So we'll say user dash IP port map user dash app1 is TCP 12345. Port TCP 12345. So if you do have non-standard applications, you can use the standard inspection, which again in this case means that we're watching 12345 go out and we're expecting source 12345 to come back in. It's not going to have an individual application level inspection. It just gives you a little bit more granular control than having to say allow all TCP traffic out and then allow all returns. So if you want to be more specific in the application rules, you would not say general TCP, UDP, ICMP. You would say allow SSL out, allow web browsing out, allow network time, but not all other default applications of TCP and UDP. Okay, also let's remove the previous TCP intercept. Let's show run include intercept. include intercept, because this configuration is now going to be taken care of by the CBAC inspection. So these are mutually exclusive. You run one or the other, but not both at the same time. So let's say show IP inspect config. Okay, this shows what are the current inspections that we're doing. We can see that the alerts are on by default, the audit trail is off, and then we could specify the individual timeout. Some of these are going to have different values, some of them are going to have different arguments, like SMTP says what's the maximum payload of your mail. So I'm not sure, I'm assuming this is in bytes, but if you check the command reference, assuming this is in bytes, this is saying like you have a limit of 20 megabytes for your particular mail message. Okay, now we do still need an ingress ACL on the return. So we're going to have an IP access list extended that says this is our CBAC return flows. And this I'm simply going to say deny IP any log, because I don't know exactly yet what the flows I need to manually return back inbound. Okay, now on that particular interface, which is F00.23, this link here, we're going to say IP inspect and the name, so the name is CBAC rule, out, and IP access group, CBAC return flows is inbound. Okay, so again here we don't need to configure an outbound ACL. We're doing the inspections out, and then the return flows are either going to be permitted by the state table or they're going to fall back to the access list. Now we can see here, just like the previous reflexive ACL, there is a log here that we're denying the return OSPF flows, and CBAC cannot inspect this. So if we were to say IP inspect name our CBAC rule OSPF, there's no inspection for OSPF. So this means that we have to go to this access list, CBAC return flows, and say permit OSPF. Now, of course, we could be more specific here. We could say just from our particular neighbor, going to the OSPF multicast, going to our unicast, and we can see now the control plane adjacency is up. But you always have to take these into account, regardless of whether we're doing the reflexive ACLs, CBAC, or the zone firewall. You always have to think about the router's local control plane. Because normally you do want to do infrastructure filtering. You don't want the router just wide open that people can send it traffic. That is what opens you up to potential DOS attacks against the router itself. So someone sending a UDP flood to the CPU, or doing TCP port scanning or a SYN attack to the router. Normally, the only people that should be able to touch the router are going to be the other network infrastructure devices, like maybe your SNMP management stations, the other routers that are OSPF adjacent, but not some guy on the internet, often whoever knows where. Okay, so next let's look at our show access lists. And we're looking at here our CBAC return flows. Now to clean this up a little bit, let me get rid of the previous one. Let's say no IP access list extended outside in or outside out. And no access list 100. Okay, so we just have our one access list that's for our return flows of CBAC. It says manually permit OSPF. If it's not OSPF, deny everything else. And let's say clear access list counters. It says it is denying ICMP from router 2 back to 10.1.0.100. And I think this is because the test PC, I think, is still doing a scan of that router. Okay, so let's look at this from the application that's on the inside. Are we able still to ping router 2, which we are? Are we able to telnet to router 2? And that actually, I think, is unrelated to the firewall. I think router 2 has this ACL 100 configured. Let me get rid of that. Okay, so we can see from the machine on the inside of the firewall, which is test PC, we're able to send our telnet, which is port 23, destination, out. And then when the return flows come back in, the session table should be allowing this. So on router 3, while the session is open, if we look at the show access lists, the CBAC entries don't get inserted into this ACL. Instead, they're in the CBAC inspection session table, which we see when we look at the show IP inspect sessions. Now, from the documentation point of view, this is what they describe as the, let's go back to the configuration guides. Configuration guides for securing the data plane for content-based access control and the firewall ACL bypass. It says that firewall ACL bypass allows a packet to avoid redundant ACL checks by allowing the firewall to permit the packet on the basis of the existing inspection session instead of dynamic ACLs. Thus, input and output dynamic ACL searches are eliminated, improving the overall performance of the engine. If we look at how to configure, it says that after the firewall is configured for inspection, ACL bypassing is performed by default. And this is as of 12.3T. So what this means is that in the older versions of CBAC, when the return flows went out, or when the initiating flows went out and they go to return, they're inserted as individual ACEs, so access list entries in the inbound ACL. In the current versions, it doesn't do that anymore. You only see the flow data in the inspection table. You don't see it in the show access list output. So depending on what your particular version is, anything that's newer, we would need to look at the show IP inspect sessions. The older versions, you would look at the show access list, and we would see these dynamic entries at the top of it. But they're saying that from a performance point of view, it's easier for the router to use the session table than do some sort of linear search against the access list on the interface. Now, if we go to the machine that has the session open and exit, what we will notice here is that router 3 is going to immediately close the session. And this is one of the main advantages of using the CBAC engine or the zone firewall engine versus the previous reflexive ACLs, where the reflexive ACLs don't have application level visibility. They're using just a timer to figure out, can the flow return back in? Where in this case with CBAC, it's actually looking at the three-way handshake and waiting for the destination to return either a fin or a reset, which means that it should delete that entry from the session table. Now, this also means from a verification point of view, when we look at the show IP inspect sessions, we have to be looking at this at the exact moment that the flow is open through the router. So this means that if we go to this VM and ping through the firewall and look at the result of this from show IP inspect sessions, once we get the echo reply back in, this eventually is going to close. So depending on what the particular application you're looking at, you may need to look at this simultaneously as you're generating the test flow to see if it's actually going through there. But once the session closes, you can see now the session is gone. But with the reflexive ACLs, it's waiting like 5 minutes by default before it removes the traffic. Now, if we do a more specific inspection, like let's say we open our web browser and browse to router 2, and when we look at the show IP inspect sessions, it should tell us that this is now an HTTP inspection. It's not a TCP inspection. So this is one of the differences we'll see versus the CBAC versus the zone firewall, where in CBAC, the order of operations is irrelevant. We don't have to deal with it. So if you configure the IP inspect TCP before the IP inspect HTTP, the router already knows to take the more specific inspection. But in the case of the zone firewall, it is going to be processed in a top-down fashion. So the order that we manually specified the classes and inside the policy map, that's going to determine the order of the inspection. So just like a QoS policy or an ACL or a route map, we would want our more specific traffic matches at the top and then kind of our fallback matches towards the bottom of the policy. But again, you can see here with CBAC what is the particular protocol that's being used by looking at the show IP inspect sessions. Now, if we also do this from router 1, let's say that we ping to router 2, or we telnet to router 2, we should see that both of these sessions were caught by the firewall because the direction of the inspection is our outside interface outbound. So router 3 is saying, I don't care what inside interface, whether we say that these are inside 1 and inside 2, I don't care what inside interface the traffic came from. I know that when it leaves on the outbound interface, where we have the inspect rule configured, when the return flow comes back in, we're always checking the inspection table before we check the ACL. So even if the ACL were to say deny IP any, router 3 would still allow the traffic flows to go out and then return, assuming they're whatever we inspected, like HTTP, TCP, UDP, and ICMP in this case. Now, there was a question previously, what is the difference between doing the inspection outbound versus doing the inspection inbound? And we'll see when we look at the difference between content-based access control and the zone-based policy firewall. When we have 3 or more zones, so if we want to say that we have inside 1 and inside 2, but they have different policies, it's very difficult to try to manage that with a CBAC config versus a zone-based policy firewall config. So again, if we look at the current setup, since we're doing the inspection outside out, and we were to say that these interfaces are in 1 and in 2 and out, this means the inspection is being done in 1 to out, it's being done in 2 to out, but it's not being done in 1 to in 2 or in 2 to in 1. Now, outbound to inbound, that's hitting the access list, and then it's going to check the session table, then the access list. So we would see the difference would be if we were to move the inspection and say that it is inside in. So again, if we said that these were in 1 and in 2 and out, if the inspect rule is configured on inside to in, we would be inspecting in 2 to in 1, in 2 to out, but we would not be inspecting in 1 to out, and from in 1 to in 2, we would follow the state table followed by any ACLs that we have configured on there. So most of the time, the inspection rule should be applied on the egress interface outbound, but we could technically apply them inbound, especially if we had different policies that we wanted to implement. So if we were to say, for example, the test PC here is allowed to do HTTP and that's it, we could say there's a rule that specifies IP inspect name HTTP only is HTTP. Then on fast Ethernet 00.11, we say IP inspect the name is HTTP only is in. Then we have an access list that would basically deny everything, and we apply that outbound. So we can see now this is this looks like the port scan. I think the port scan is running on the back end, still in the background of this guy. Which it is. But we can see as soon as we applied that policy, it started to drop traffic in because it was no longer part of the inspection policy. So you can have separate inspections on separate interfaces, but it gets a little bit more complicated because let's say, for example, now that we wanted to say that this is the DMZ, this is the inside, and this is the outside. We want a policy that is inspecting inside to outside, but a separate policy that goes in to DMZ, and a separate policy that goes from out to DMZ, because this is like where our web server is. So we want the internal users to be able to hit the web server, but this is a different policy than people on the internet coming to hit the web server. The problem is now with CBAC, where do we apply the policy? Do we apply it on the DMZ out? Do we apply it inside in? Do we apply it outside in? Anytime we have more than 3 zones here, this is where this configuration starts to become unmanageable. Because with CBAC, there's no way to do a direct correlation to say this inspection is from inside to DMZ, but not from inside to outside. This is essentially what the zone firewall is for. Because on the back end, the zone firewall is still using the CBAC inspection engine. The only thing that we're changing is we have a more granular interface into what specific inspections are actually occurring. Now, as I mentioned here, additionally with CBAC, the same that is true with the reflexive access list or with the content-based, or with the reflexive access list and the zone-based policy firewall, we do also need to account for the router's control plane traffic or anything that is a non-standard flow. So again, if we look at our current setup where we are inspecting the traffic as it leaves the outside interface of router 3, so we're doing our inspection outside out. If we have a non-standard application like our trace route that comes from router 1, when the UDP flow goes out, this would be inspected, but when the return flow that is either our ICMP TTL expired or the time exceeded, as well as the ICMP port unreachable, since the CBAC engine does not have a specific inspection to tie these two responses to the outbound request, that is still going to be dropped. So again, anything that is a non-standard application, you can define the custom inspection for them, but if the outbound flow does not equal the inbound flow, it's still not going to be allowed. So we could see this from router 1. If we do a ping to router 2, ICMP echo and reply, this is a standard flow, so that's not a problem. The same is true with a telnet. This should fall under our normal TCP inspection. But if we now try to do a trace route to router 2, the traffic gets to router 3's inside interface, no problem. But then if we look at router 3, we should see a log where the CBAC return flows is denying the ICMP time exceeded as the traffic returns. So since there's no application level inspection for the trace route, we would still need an exception for this particular flow. So when we look at the show access list, we would need to say not only to allow our local OSPF traffic, if we say IP access list extended the CBAC return flows, we would also need to permit ICMP any port unreachable and ICMP any time exceeded. Okay, these two would be for our trace replies. Now we'll see that the same is true here for the ASA, that even though it is inspecting UDP outbound, it does not have the ability to match up the inbound ICMP replies to the outbound trace route. So now on router 1, if we do the trace, we could see that it is allowed because the return flows are matching these port unreachables. Now we'll also see that the locally generated traffic on router 3, again, is going to have the same type of problem. So router 1 was able to ping router 2. If we do the same thing from router 3, who is the one that's actually doing the inspection, so on router 3 we ping 150.122, we could see on the inbound ACL for the CBAC return flows, the echo reply is being dropped as it comes back in. Same would be true if we tried to do a telnet from router 3 directly. The TCP response is getting denied on the ingress ACL. Now with the reflexive access list, we saw that essentially the only solution for this would be to either configure the ingress ACL as the exceptions or do some sort of trick like local policy routing. But in the case of the CBAC, we have this option for the router traffic when we're doing an outbound inspection of TCP, UDP, or ICMP. Now again, it's not going to work for everything like we saw. It's not going to work for OSPF. But if we go to router 3 and show run section inspect, we could change a couple of these rules like the TCP one to say include the router traffic, and the same for ICMP, include the router traffic. So now when we do a telnet, and let's jump back to router 3 and look at the show IP inspect sessions, we see now the session data from 3 locally to router 2 is included in this session table. So again, what this is essentially doing is changing the order of operations of where is the classifier. Does the classifier happen before the router generates its local traffic, or does it happen after? By default, the classification happens before the router generates the packet, so it's never seen by the inspection engine, and it doesn't know to allow the return flow back in. But with this option, the router traffic, it's saying generate the local traffic first, then do inspection. So I now know that when the return flow comes back, it's going to myself. Now this is also another change that we'll see in the zone-based firewall, is that we have the notion of the self zone that is for the local traffic from the router going out or from going out to the local router. So we can define a specific inspection that says allow OSPF to myself, allow this particular device to telnet into me, but only from the inside interface, not from the outside interface. So CBAC doesn't give us that granular of control. We would still need to use an ACL for the exceptions, or just to say that for this particular type of flow, generate the router's traffic first, then go through the inspection. Now, as I mentioned, there's also a way that we can change the order of the return flow tracking on the way back in. So normally, we inspect the outbound flows. When the traffic returns, check the state table. If there's not a match, then check the access list. If we were to say IP inspect TCP block non-session, this says before we check the ACL, drop all other TCP traffic. So let's say, for example, we go to router 3, and let's simply remove our current rule. Let's say no IP inspect name CBAC rule. and show run include inspect. Okay, also remove that other, actually we will use this rule that says HTTP only. But I want to apply this rule on the outside interface out. So on router 3, we're now going to have a rule that says HTTP only, and we're applying this as an outbound inspection. So when traffic comes from the test PC and goes out, if it is a web flow, it hits the inspection engine. If it's anything else, it's still going to be allowed because we don't have an outside out ACL, which means that the router is going to allow the traffic out. The real question is the router going to allow the traffic back inbound? Now we'll see that's the same case for the ASA. ASA will always allow outside out traffic, but the real question is, are we going to allow outside in, which are the return flows? So whether or not the traffic is getting inspected doesn't have anything to do with whether the traffic is allowed to leave. So multicast can go out, pings can go out, telnet can go out. The question really is, when the traffic returns, am I going to permit it or am I going to deny it? So on router 3, we have this rule that says only allow web traffic. Currently, I have this applied inside in, so I'm going to remove that. No IP inspect HTTP only in. Instead, we're applying that out on the outside interface. If we show run on that interface, do show run interface F0023, we have this access list that says CBAC return flows. Okay, for now I'm going to delete this and we're going to recreate it. So no IP access list extended, CBAC return flows. Instead, we're just going to have an access list that says permit any, permit IP any. And this is applied in on that same interface, IP access group, permit any, in. So we're only inspecting web traffic out, but we're saying on the return trip anything can come in. So we would then assume if we go to router 1 and we ping router 2, that should be allowed because the access list in says permit whatever. Same would be true for the telnet traffic. So even though we're not inspecting this, if we show IP inspect sessions, we don't need to inspect it because the return ACL says to allow it. Okay, now we're going to add that other command that is essentially enforcing the strict filter, which is IP inspect TCP block non-session. This goes globally. IP inspect TCP block non-session. From router 1, let's disconnect that telnet, we should still be able to ping. If we telnet, and I actually may need to remove the inspection and reapply it. Let's do this. And let's also do this on this access list that we're using, permit any. Let's say IP access list extended, permit any. 10 permit IP any log. Let's see what are the actual matches that we're allowing. Okay, it's saying it's permitting our OSPF control plane. The telnet is being allowed. I actually may need to be more specific in the ACL here. Let's do this. IP access list, permit any. Let's get rid of this no 10. We'll say permit TCP any log UDP ICMP and OSPF. We know we're using that for our routing. Okay, then the ACL is applied in on that interface, permit any in. If we do a ping, 3 should log this as it came back. And if we let's say show IP inspect sessions, it's not hitting that permit. Now it is hitting the permit. Let's try it from the other side, from the VM. Okay, we should be able to ping outbound, which we can. The telnet is allowed. Let's see, is the web browsing allowed? And let me try this in the reverse direction. Let's say from 2 in. Telnet 150.1.1.1, which is fine. This should be applying, let's say show run in inspect. Let me do this. Let me remove the access list. Show run interface faster than a 0023. Okay, so we're doing the inspection out, but there's no ACL now configured inbound. So let's see, can 1 ping to 2, which it can. And let me remove this and reapply it. What we should see is that it's going to allow the ping, but it should drop the other flows that are not getting inspected. And let me make one more change to this and we'll see if it takes effect. Instead of inspecting outside out, let's inspect inside in. IP inspect HTTP only in. Let's do one more change before we go on. Let me reset the session table. Clear IP inspect sessions. And I need the number. I don't think we can do for all of these. It says to block packets that do not belong to the existing firewall TCP session in the inbound and outbound direction, use IP inspect TCP block non-session and global. By default, TCP packets that do not belong to an existing session of the firewall are allowed, which is normal. Let me do this real quick. Before we move on to CBAC, let me reload this router because we made a bunch of changes with it. Sometimes you will find this, and you, within the scope of the lab exam, don't exclude this as part of your troubleshooting process, that if your configuration looks good and it's not behaving the way that you think it's supposed to, save the config and reload, move on to something else, and then come back. Sometimes you'll see that resetting the process will actually fix the problem. So let's take about a 10-minute break here. When we come back, I'm going to not spend too much more time on this with CBAC, but we're going to get into the zone-based firewall and then look at the differences of why would you want to apply zone firewall versus the CBAC inspection.